Hi there, this is Mr. Cardoso, and in this video we're going to be talking about exceptions. So we're going to be using our fraction example to continue this. It's kind of at the end of the objects unit, even though it doesn't really have 100% to do with objects. We can use exceptions in objects, so that's why we're talking about it here. And we're not going to go 100% into detail on exceptions. We're going to try and cover the most important parts so that you can actually use them when dealing with certain situations with objects. So before we get there, let's just review. We're going to be using our fraction example. So we have an object class fraction that has a numerator and denominator fields that define it, and all the stuff that we've been doing over all the previous 16 video lessons that we have in this series. And then we have our fraction calculator class, which is what the secondary programmer would be using if they wanted to do, and this is just an example, right? Fraction calculator, maybe they want to do some calculations with fractions and they want to use the fraction class to be able to do that and create some fractions and manipulate them in various ways and maybe make a calculator and so on. So the secondary programmer is doing this. This is the primary programmer making the fraction. This is the secondary programmer, as we talked about before. And then at the end of this line, we have an end user. The end user is the person probably using the fraction calculator class, as it has a main method. You can run this program. Can't run this one, there's no main method, but it's used in this class for a specific purpose. So the end user is the person who's paying for the program and likely paying for the program or using the program, and they want the program, of course, to be good. That's probably why they're paying for it. So with that being said, let's talk about, before we get to exceptions, let's talk about other errors you have experienced. So for example, right now if I hit the compile button, there's a warning here, but let's just take that out, we don't need that. But there's a warning, now there's no warning, there's no compiler error here, and the program, seemingly will run. So what does this program do? We've created a fraction with a numerator of 3 and a denominator of 4, and we've printed it out, and you can see down here 3 over 4. Okay, great. Now let's take out that semicolon. What kind of error is this? Hopefully recognize this is a compiler or syntax error, because the compiler won't let the program continue. It found that there's an error, and it doesn't understand how to translate this code. It doesn't understand, what is this command? It doesn't have an ending. Is there something coming after it? So the compiler doesn't understand, it can't continue. And so it's telling you, the programmer, to fix this problem. And I'm sure you've seen many compiler errors over your years of programming, but it's telling you to fix the problem before you can continue. Compiler errors never get to the end user. The end user never sees this, because before you can even release the program, you have to fix all of your compiler errors or syntax errors first. So I'm going to put the semicolon back in there. That's an example of a compiler error. So now if I hit the compile button, it works. Because we put semicolon back in, no compiler errors. What about this one, 3 over 4? So nothing to do with this fraction. In fact, let's just take this right out, comment that out there, and we'll hit the compile button. So that compiles. What do you expect this to give us? What do you expect this to print out? So this should print out 0.75, right? But does it? Let's hit the run button and find out. It prints out 0. So this is an example. If you wanted it to print out 0.75, this is an example of a logical error, because the program, there's nothing wrong with the program. Java doesn't know that this is not what you want. It thinks maybe you want 0. But this is an example of logical error if you want 0.75. The reason it's logical is because the compiler can't catch it. According to this, it's in the right form. 3 divided by 4, it's in the correct form. You're dividing two numbers. Now the 3 over 4, why are we getting a 0? Because it's integer division. These are both integers. So if you take either one of these and change it to a double by adding a 0.0, You can do it to both, or you can do it to just one, and now that will do regular division. So if I hit the compile button and now hit run, and there we have 0.75. So what we had before with the 3/4 and getting the 0, that's a logical error, and you've seen those lots as well. So when you're doing programs with loops and the program doesn't multiply correctly or do whatever it was supposed to do, that's an example. But it does compile, that's an example of a logical error. Your calculations come out wrong or something like that. So those are all logical errors. Then there are other kinds of errors. What about if I do 3 divided by 0? Well, you know from mathematics that you can't divide by 0. Anything divided by 0 is undefined. So if we try to divide by 0, what happens in this program? Does it compile? Does the compiler stop you? So let's try to compile it. The compiler doesn't stop us. It doesn't know. And that's because the compiler doesn't know what these numbers are. It just says, I see an integer, I see another integer, and you're allowed to divide two integers. That's how the compiler looks at this. It doesn't realize the values of the integers until runtime. So it compiles. When we hit run, what happens? We get this arithmetic exception. So this is called kind of like a runtime exception or runtime error. It's an error that gets to the end user because the compiler didn't catch it. So it can get to the end user and you're using the program, everything's going great, and depending on something, this thing comes out. For example, maybe you could say, well, why did you put a 0 here, Mr. Cardo? So maybe I wouldn't put a 0 there, but maybe it could come from the user, with our scanner or kvreader.next int. We ask the user to enter that value, and the user enters a 0. And then again, you're in the same boat. So the compiler can't know what that value is. It cannot know what that value is at compile time. The only time it figures out what the values are at runtime, and at runtime it's probably too late, and that's where you get these exceptions. So let's talk a little bit about exceptions. Here on the right hand side, I've got a diagram. So we've got different kinds of exceptions. We've got something called a checked exception and then a runtime exception. What you're seeing here with the arithmetic exception is an example of a runtime exception, which is not caught by the compiler. So as you can see, the compiler didn't catch it. And so we'll get to this a little bit later on. Now, let's go back here to our fraction. Let's return to fractions. So let's print F1. So compile that, hit the run button, we get 3/4, everything's great. Now, if you recall, what happens when we try to put 0 in the denominator? So here, we have set this in this is the constructor that's called numerator and denominator, and we've said if the denominator is 0, we wrote an if statement, and we said, hey, you can't do that, denominator set to 1. We set it to 1, and we sent that little message out. So let's just review what happens. We hit the compile button, and we hit run. So now what happens is that we created this fraction, but in that constructor we've got our message, hey, you can't do that, denominator set to 1, and then we get 3/1, which is printed for our fraction. Now that's fine, that's okay, but it's not the best solution. It's not the best solution because you're removing, as the primary programmer. Now remember, the person programming fraction.java is not necessarily the same person who's using that class. For example, this class might be used by hundreds or thousands of different programmers, all doing different things with the fraction class. So right now, as the creator of the fraction class, you are determining what happens, what gets to the end user in that secondary programmer's program. You're not giving any flexibility to that secondary programmer. What's worse is that you're setting the denominator to 1. And that might be a bad thing. The secondary programmer might prefer you to stop and say, hey, something went wrong here. Now you fix it. And so that's where exceptions come in. So rather than doing this and just sending a message and setting the denominator sort of randomly to 1, what we're going to do is we're going to say throw new exception. And you see that new keyword in here. That's because exceptions are objects. So we go throw new exception. This is calling a constructor, in fact. And we have this new keyword now, throw. Now what this does is, when we saw that exception before, the arithmetic exception, hopefully you remember that, when we tried to divide by 0, that was an exception that was thrown automatically by Java. So Java threw the exception because it got a 0 at runtime and it said, hey, this is not good, so it threw an exception. It's like it stops everything because something's not right. We cannot continue the program. So what we're doing here as the primary programmer is we're actually throwing an exception on purpose. We're saying, hey, the denominator can't be 0, so we're going to throw an exception and stop everything, right? Now this is an example because it says exception. It's not a runtime exception. So this is an exception. So this is over here. This is the checked example. So these are caught by the compiler. And you must use a try-catch block or pass it on. We won't get into that, but you must use a try-catch block. Otherwise, you'll get a compiler error. So I'm going to go back over here. And now let's try to create this fraction again. Let's just hit the compile button. Let's see what happens. So this is what we've done. We've forced a compiler error. And remember, compiler errors can be good things because it makes that secondary. So we're forcing that secondary programmer to realize, hey, something went wrong here. This is not good. So I need to fix it. And so that's why we're forcing a compiler error here. So when they do this, they realize, okay, I can't do that. What's even better is in the constructor of this, you can even put that message there. Okay, so again, if I try to compile it, it's the same thing. It doesn't help anything, but you are allowed to put that message into the constructor of the exception. So that message does come out, and we'll see that in a few minutes. But now again, you still can't do it. So that's what this means right here. You must use a try-catch block. Well, what if I change this to 4? Does it work then? Again, it still doesn't work because it's saying unhandle exception. So it's saying that I don't know what these numbers are, again, until runtime. So the compiler's saying, regardless of what these numbers are, you can't do that. So now, because we have a throw new exception, the secondary programmer has to use what's called a try and a catch block. So basically anything that can cause an exception to be thrown. So this is a constructor, this is the constructor here, and this constructor throws an exception. So anything that, because we're calling that, anytime we call that constructor, we have to use a try catch block. And so we say exception, and you have to name the exception. Think of it like the parameter list in a method. So you have to, we just typically say exception E, which will catch all types of exceptions. You can give it a name if you want. And at this point, if you get to this block, so if it does this code and all goes well, it'll continue. So let's hit the compile button. Unhandled exception. Now we're getting an error because this class, this constructor throws an exception, but so you have to tell the secondary programmer. Now remember, these things show up. The method headers show up for the secondary programmer to see. So if we say throws exception, now we're declaring it in the method header, in the constructor header here, we're declaring it. So now if I hit compile, I have another problem, because anytime now that I use this, I have to say throws exception. So this is what I mean by it must use try catch block or pass it on. We'll continue.